Hi everyone, I'm Huda. You guys can call me Miss Lai. And today we will conduct about the organic chemistry, about hydrocarbon, which including alkane, alkene, and alkyne. So first we look at the meaning of hydrocarbon. Hydrocarbon is the substance that only contain carbon and also hydrogen. And today the three main group in the hydrocarbon that we learn, which is alkane, is saturated hydrocarbon. The saturated hydrocarbons means that there is no multiple bond between the carbon and carbon, and the alkene and alkyne is unsaturated hydrocarbon that contain multiple bonds like double bond and triple bond. So first we look at the some important things about the alkane. First, this only contains a single bond, and also the general formula is CnH2n plus 2. So next, there are many naming of organic chemistry. So according to the number of carbon, we can give the naming like methane, which is all the alkane naming, the first name is A and E, which is N, and the first part we put like if you have one number of carbon, we put as methane, and two number of carbon is ethane, 3 is propane, 4 like butane, 5 is pentane, 6 is hexane, heptane, octane, nonane, and decane. So next is about isomer. Isomer is the substance which have the same molecular formulas but different structure. So like the C4H10, we can draw it in a chain, or we can move one C to the number of C of the number 2 of the C, have a branch we call isobutane. Then next we look at there's many types of isomers such as structural or geometry isomer. Geometry isomer is like trans and cis trans isomer. So there the classes of carbon, they have 4 classes. First is primary carbon, which means that carbon they only bond to another one carbon only. Secondary carbon, as is secondary, so the carbon will bond to 2C. And tertiary is bond to 3 other carbons. And we have last quaternary carbon, which means that bonded to 4 other carbon. So next we will look at the nomenclature. The nomenclature of this alkane is based on the IUPAC rules. IUPAC is the short form of the International Union of Pure and Applied Chemistry. So they have 4 main rules when we giving the name to the hydrocarbon. Like the first is the main chain. What is the meaning of the main chain? The meaning is the longest carbon chain. For example, like this, like this. So we have this is one carbon, one carbon, one carbon, one carbon. So instead of this, we need to take this, which is the longest carbon chain. And the second is we give the numbering to the main chain, but the numbering should start from the closest to the branch and or functional groups such as like OH, double bond, triple bond, those functional groups. And also we should give the branch with the lowest numbering, and also when you give naming, you should based on the alphabetical rules, which means that like we have methyl and ethyl group, we should put the ethyl on in front and methyl at the back because E comes front of M. And next is the properties. We have 2 types of properties. The first is physical properties and the second is chemical properties. So physical properties will including the boiling point and some bonding. First, in alkane, alkene, and alkyne, The boiling point will increase when the number of carbon increase as the surface area increase, because more longer the chain, more larger the surface area, so it will be more harder to break the bonds, so the boiling point will be higher. So if we have ethane with 2C and propane with 5C, so the propane will have the higher boiling point. Next is the boiling point of the isomer will decrease with branching because of decrease of surface area, which means that if we have the same number of C, like C4H10, same is the butane. If one have branch, one don't have branch, the have branch one will have the lower boiling point. Okay, next we will look at the we'll look at the solubility. Because the alkane is non-polar, so because there is no electronegativity between C and H, so it will also dissolve in non-polar or weakly polar organic solvent and cannot dissolve in water. Like the example of the non-polar solvent is CCl4 and C6H6. So it is not soluble in water as it cannot form the hydrogen bonds between H2O. And next is cycloalkane. There is a chain alkane and cycloalkane. The cycloalkane is in a ring form, so all the C will be connected. And the general formula of cycloalkane is same with alkene. Next, we will look at the preparation. So there is some reaction that we can do to prepare the alkane. So the first is hydrogenation. Based on its name, hydrogenation of alkenes. Hydrogenation means we add the hydrogen on the double bond of alkene. So we break the C double bond C and adding 2 hydrogen with like 1C, we add hydrogen, and this is the double bond. So the double bond will break and be adding both H on it. So the catalyst, the component that we use to reaction is hydrogen H2 with the catalyst like PT, PD, or nickel and I. So next is the reduction of alkyl halide. Alkyl halide also we call as haloalkane, which is halogen and alkane with like HCl, HBr, and so on. So in this reaction, the basis that we use is haloalkane, like the alkane with Cl, like this. R is R group is the like hydrocarbon group. So the X is the halogen. So the X will directly transform to H with the reactant, the reducing agent like zinc with CH3COH, LiAiH4, and NADH4. They have 3 types. We can use one of them to reduce the Cl to H. The next preparation is via Grignard reagent. Grignard reagent is formed if we react the haloalkane Rx with Mg in the presence of the ether, and we can form RMgX, like RMgCl, CH, CH3MgCl. And we use this Grignard reagent with RMgX to react with H2O, so we can form alkane. RH with the side product MgOHX. So the reaction of alkane is only one. It's very easy, which is halogenation. Halogenation is adding the halogen to the alkane. Like the types of the example of the halogen is like Cl2, chlorine, fluorine, bromine, iodine. So when we react the Cl2 with the alkane like CH4 in the presence of heat or light, we can write it as UV or HV, and we can form the haloalkane like CH3Cl, CH2Cl2. This is based on one rules we call which means that the Cl will bond to the higher order C, and this is our major product. So you can see here, here is the CH3, CH2, CH3. He undergo the halogenation. The Cl we can bonding with two-way. If you want the major product, the C need to have the higher order like secondary, which means that they're bonded to 2C. But for the minor, it's only bonded to the first order C. So this is all about the alkane. So next, we'll look at the alkene. Alkene have more reactions, so it's a bit complicated. So as we just said just now, alkene is unsaturated hydrocarbons, which means that it contains the multiple bond. For alkene, it is double bond. So this naming we give the parent's name is start with E and E. Like we will write, if one C we will write in methene, methene. So the general formula is CnH2n. So if you see there is a double bond in the substance, which means that it is alkene, if no other functional group. So the nomenclature still same. It will use IUPAC rules. Also, we need to consider the main chain first, the longer chain, and then give the numbering based on the lowest number of the functional group or branch, and also depend on the alphabetical. So if example, we look at one in, this alkene have 4C, and then the double bond on the first C, so we give the name put 1 in. We look at the other substance with the branch, we can look at this. Now here we need to consider the first thing, the longest chain. So the longest chain is 1, 2, 3, 4. So this the parents name will be butene, and we look at here the functional group double bond on the first carbon. So this is put 1 in. But here we have one substituent, we call it methyl group. So it will become 3 methyl put 1 in. So okay, if we have the cycloalkene, which means that the alkene is in the ring. So every numbering start with the double bond if we have cycloalkene. So 1, 2, 3, 4. This is the substituent need to have the lowest numbering, but 1, 2, 3, 4, 5. If we start with this way, it will become a higher number, will become number 5, so cannot, we should start in this way. 1, 2, 3, 4, so the substituent we add the carbon number 4. And this is called third butyl. So the nomenclature will be like this. For third butyl cyclohexane. The one can ignore because all double bond will start with all the numbering will start with the double bond. Next, we look at some example also. If you have the substituent, like maybe somebody will ask how we can start our numbering. If you have substituent like this, all the numbering should start with the double bond with the substituent. So here must be 1. Like here we have 2 substituent, but the numbering should start with the double bond, have the substituent. So start with here 1, 2, 3, 4, 5, 6. So also the naming should follow the alphabetical rules. Like here we have 3 substituents: bromo, chloro, and methyl. So B, C, and M. So we should follow alphabetical rule. B come first. So it will be the bromo, chloro, and methyl. So next is the geometry isomerism. It will have the cis trans. Cis is mean that the like this is cis trans isomer. The cis, which means that both sides have the same substituent like this, CH3 at the same weight, and both the below is HH. So for trans, it means that in the opposite way. Like here is CH3, but the other CH3 is at here. This is trans. But we now have a new system. We call it EZ system. We normally use for the alkene that more than 3 substituents, but it also can use with 2 substituents. So this is depend on the atomic number, the molecular weight. So like here, if we have the substituent, which have the substituent that have larger atomic number on the same side, we'll call it Zusammen, which is symbol by Z, and we use E when the substituent with larger atomic number is on the opposite way. So we look at the example here. The number of atomic number in this substituent in the higher part is Cl. Cl is bigger than F. We can look at the here. This is chlorine. So chlorine have higher atomic number. So it should be the priority. And we look at CH3 and H. Of course, CH3 will have a larger atomic number than H. So all the substituent with the larger atomic number is on the same side. We call it Z. So we give the numbering Z first, and chloro, because on the first C here. So 1 chloro, 1 fluoro, chloro, both on the first carbon, and then the prod 1 in, because the double bond is on the first carbon. So if the E at the egen is with high priority in the opposite side, so we can see now the chlorine is at here. So with the CH3, it becomes the opposite side. We give the numbering start with E. But for the cis trans, if we have the same substituent like this is like H. Suppose here be like CH3, but this also H. So this is non-cis trans. Also same as this. CH3, they have no same substituent in the here part, so this is not following the system. It's not geometry isomerism. Next, also we look at the physical properties. The physical properties of alkene is similar to alkane. So the alkene with C2C to 4C act as gases. From C5 to C18 act as a liquid, and with the number of C larger than 18 will react like the wax like solid, it will be like solid. And this alkene also is soluble in water, as it cannot form the hydrogen bond with water, but it's soluble in non-polar organic solvents like benzene and CCl4. Because C and H also is non-polar, there is no difference in electronegativity. Next, we will look at the preparation, how we can form an alkene. There have some way. The first way is dehydration of alcohol. Dehydration, what's it mean by dehydration? Hydration is water, H2O, D is you take out the water. So you take out the water from the alcohol. The alcohol, the functional group is OH. So we look at dehydration of alcohol. First we have an alcohol, and our reactant is the strong acid like H2SO4 or H3PO4 in the high temperature 200 degrees Celsius, or we can represent it with heat. So we look at here. This is our alcohol. This is our group. We will eliminate the HOH, take out the H2O, and we will form the double bond with the side product H2O. Similar like this, H2O, the reactant, strong acid and heat. We form the double bond and also the H2O. This will follow the set. It will follow the set rule, which means that the H2O should have more other groups between them. As you can see, we'll see at next example. The second one is the dehydration of The set rules means that the most highly substituted double bond is the major product. Similar as the halogenation in alkane, we also have major and minor product like this. So it's in the middle. We say that we need to eliminate H and OH, right? But here have OH, here also have O, here have H, here also have H. So which H should we eliminate? So if you want to form the major product, we follow the set rules, which means that the C double bond C will be highly substituted. So if we want major, we will form here. So the product will have two substituents in here, like one in here, one in here. So the C double bond C have more substituent, and for the minor, we will form at here. So it will become only one substituent in here. So this is minor. Okay. For the stabilize, the first carbon cation will be unstable and more difficult to form, and the tertiary carbon cation will be more stable and easy to form. So if you want to do the dehydration, the more easy to undergo dehydration is tertiary alcohol, as it will form tertiary carbon cation. The next is the hydrohalogenation. The hydrohalogenation, like we said just now, hydro is hydrogen, H2, halo is halogen, Cl, chlorine, like that. D is we eliminate, so which means that we will eliminate H and halogen. So for this, we also follow the set rule. So we look at the example here. This is the thing that we need to eliminate, which is H and X. X is the halogen, H is hydrogen. So we use the reactant KOH in alcohol with heat. So we should follow the set rule, form the double bond here, because we already take out here, so we will form one bond here with the side product KX and H2O. So we look at the real product. We also have the major and minor. Okay, first we look at this. We need to eliminate this is X, this is H. But we have both H. We can choose to eliminate from here and form double bond here or form double bond here. But if you want to form major product, you should follow the set 0 with the highly substituted C double bond C. So we should eliminate this H and this BR. So we will form the major product here. So we will have two substitutes. But if you want to form the minor product with less substituted C double bond C, so we will eliminate this H, this BR, form the minor product C double bond C at here. So next, we will look at the reaction. So there have many reactions in alkene, but they have same idea, which we break the double bond and add two things at the double bond. So we look at the first, hydrogenation. As we learned just now, we will dehydrate the hydrogenation of the alkane to form alkene. But here we add back the hydrogen, so it will form from alkene to alkane. So the reactant that we use also, of course, hydrogen H2 in the presence of the catalyst PT and I or PD. So here CH2, this is ethene with 2C. So we will break this double bond. So adding one H here, adding one H here, forming ethane. So the double bond will disappear. So this low pressure is not important. Focus on the H2 and also the catalyst only. Next is halogenation. Halogen is group 17, chlorine. So halogenation means we add the halogen on the double bond. Okay, sorry. So we look at the general one first. Here, this is double bond with X2 like Cl2 in the presence of the CCl4, or we can use CH2Cl2. So we add X here 1 and 2 like this. This is because of the size of the halogen is quite big, so we will put in the opposite side. And this reaction only can conduct with bromine and chlorine only. So we cannot do this product when using iodine or fluorine. So we can only use bromine and also chlorine. So we look at one example. This is the cyclohexene. Here is the double bond. As we want, we will break the double bond, adding one BR here, one BR here, so the double bond disappear, adding two BR. Next is the Markovnikov rule. Markovnikov rules means that the H will add to the C with more number of H. This is the main thing about the Markovnikov rule. So the next reaction is electrophilic addition. When first we use the reactant acid. When the alkene add to the acid, what will happen? Acids such as HCl, HBr, HI, and so on, like the first acid, HI, this is the alkene. So the don't have substituents, so the Markovnikov rule is still okay, like just add one H1 I here, so we form this. But for, let me see. Okay, here. HBr. Now we will have this. For double bond, here only have one H, but here have two H. And follow the Markovnikov rule, the H need to add with the C with higher H. So it means that for the major product, we need to add C at here and BR at here. So we will form the major product like this. The BR should be on here. But for the minor, you just opposite way, you add H at here, BR at here. But basically, we will form the major product instead of minor product. So we look at other example also. Sorry, let me find the example. Okay, here. This is the double bond, and the first C we have two H, but the second C we don't have any H, so the H should bond to the C with higher H, so the H must bond with here, and the X group like Cl should bond at here. Okay, next is beside of Markovnikov rule, we also have anti-Markovnikov rule, which means that just now I say the H will add to the C with higher H. Now the H will add to the C with lower H. In the condition, we have H2O2. So when HCl added with H2O2, this is our reactant. We're not gonna following the Markovnikov rule. Instead, we will following anti-Markovnikov rule. So just now I say that like here, this one, 1, 2, 3, 4. So here don't have H already, but because we have H2O2 anti-Markovnikov rule, H will still substitute in here, like the lower H. The H will substitute at here, the I will go to here. So this is anti-Markovnikov rule. If we don't have H2O2, we just have HI, it should follow the Markovnikov rule. H will go to the place with higher H here. So this is the difference between them. So be careful of the H2O2. Then is the addition of sulfuric acid. Sulfuric acid is H2SO4. So what things that we added is H and O SO3H. H2SO4 actually is H bonded to O SO3H. So this is alkene, follow the Markovnikov rule. So we added this CH3, CH3, the H will bonded to the double bond at here, C with higher H, so H go here, or SO3H bond here, so it will form this. CH3, C or CH, or SO3H at here. Next is addition of water. Water just the reactant that we use, of course we need to have water H2O, but we need to have a reactant we call H+. It should have an acid catalyst, so it also follow the Markovnikov rule. So in alkene, you should be careful of this Markovnikov rule. So we look at one example here. CH2, C double bond here, so the double bond at here. We have the reactant H2O in acid catalyst. So H bonded to the C with higher H here. So another OH will go to this C, forming this is alcohol. OH means that this is alcohol. So next is we adding halogen in water. We'll use H2O and one halogen like Cl2. So we look at the reaction. here, this is C double bond C. For study H2O, we're using H and OH, right? But in here we will use OH and also X. X is halogen group. So it will follow the Markovnikov rule also. But here is the X will go to the C with higher H. Like here, I give you one example here. This is CH2, CH by the same study. This is the double bond here. For H2O, if you have H2O and H plus only, we're using H and OH, right? So the H still bonded here, but in this case, we have Cl2 in H2O. Cl will go to the C with higher H, so the Cl will bond it here. The another OH will go here. So you can see we will form Cl here and OH here, double bond, right? Adding these two things. So this also be careful because it's quite similar with the addition of water. Next is oxidation. Okay, first we have a bit special one to form alcohol with following the Markovnikov rule. Anti-Markovnikov rule, sorry. So this is our examples here. We have C double bond C. So here have one H. So this C will be have a higher number of H. But the reactant we use is BH3 in THF and H2O2 with the OH. So because of the H2O2, we will follow the anti-Markovnikov rule. So the H and OH will bond H will bond to here, at here, the C at here. So you can see C. Sorry. The H will bond to here, anti-Markovnikov rule. So the H will go here, the OH will bond it here. So if you see H2O2, remember anti-Markovnikov rule. Another example like this. So which is the C with the higher number of H? This one, right? So anti-Markovnikov rule, the OH bond to here. H go to the lower C, lower H of C here. So it will bond to H, this will bond to the OH. Next is ozonolysis. In ozonolysis, the reactant that we use have two types. One we can use this. The upper one is OH, lower one is CH3 2S. But the other reactant we can use is O3 with zinc and H2O. Let's see. So this ozonolysis is very easy. We just break the double bond and add the O at both sides like this. So we look at the example here. Here is the double bond. We'll break it and add one O, and we'll form this. Like this. The other example we look at, we have the cycloalkene. So here, how we can break this? Same, we break the double bond and just add 2 O to the double bond that we break. So we will form this. At the same, we break the double bond and you form this. So the other things for oxidation is, from outside the ozonolysis, we will use the other reactant we call concentrated KMNO4 plus heat. This is a strong oxidizing agent. So for this, if you see KMNO4 concentrated with heat, actually they have 3 cases. So if you look at here, this C don't have any H, right? So it will just break and form and add one O like the just now one. It will just break and adding one O like this. But here this C have one H. So after you break the bond and adding the O, the H will become OH. So you pour carboxylic acid like this. So you break it and add the O and the H will become OH. So what happens if you have two H? So if here you have this also H, if we cancel it become H, you now have two H, right? So it will directly become CO2 plus H2O. You will not form any double bond O, it will just become O. It actually is C double O forms CO2 plus H2O. So next we have the visual test, how we can differentiate between alkene and alkane. So we have two tests. First we call it bromine test, second is Bayes test. So the bromine test is actually same with the halogenation, which means that we add halogen in the presence of CCl4 or CH2Cl2 like this. So the C double O, if this is alkene, we have double bond, we can break the double bond and form one Br here, form like this. So actually the bromine, the color is the reddish brown. Bromine is reddish brown. So when he can react with the alkene, it will become colorless. So you can see the transform of the color from the reddish brown to colorless, which means that the hydrocarbon that we use is alkene. So what happens if you have alkane? It will don't have any reaction. So second, we look at the Bayes test. Bayes test we use CaMnO4, diluted CaMnO4 in the presence of the cold. This is cold, and also we have the base OH. So the CaMnO4 is in purple color. After it can react, it will become brown. It will form brown precipitate. So in this reaction, we just break the double bond and add both OH on it with the side product MnO2. This MnO2 is the precipitate. The color is brown. So if we have alkene in cold and CaMnO4, diluted cold and CaMnO4, so we will see the color transform from the purple become the brown precipitate. We will form brown precipitate. So this is for the alkene. Now we look at the last one, alkyne. So for alkyne, we have triple bond. And the general formula is CnH2n minus 2, and the naming ending with Y and E. So alkane is ANE, alkene is ANE, alkyne is YNE. So it looks like this. So we have triple bond. For nomenclature, same. We need to choose the longest carbon chain that contain the triple bond. So and next, we should be careful because alkyne is kind of different. If you give numbering, you should start at alkene, because the priority of the alkene is higher than alkane. So if you have double bond and triple bond in one substance like this, the numbering, the lowest numbering should start with the alkene, but our parent still alkyne. This is the important thing. So we have two types of alkyne. First is terminal, the second is the internal. Terminals mean that the triple bond at the corner, the most left side or right side, and the internal means the triple bond in the middle. So the terminal alkyne will have one H, we call it as acetylenic hydrogen. So the reaction will be different when we're using terminal alkyne or internal alkyne. So the physical properties is actually same with alkane and alkene, don't have many difference. So we just go to the preparation. If we want to form the alkyne, we can form from the dehydrohalogenation of alkyl halide, which means that the alkyl halide like this. So if you want to form terminal one, you should use this is the Na-NH2 150 degrees Celsius in H2O. You can form terminal alkyne. So hi, for the continue with the part that I'm missing. First is the bad alkyne. So now let's add the alkyne. Okay. Alkyne is one of the unsaturated hydrocarbon that contain triple bond. So we look at first thing. There's some basic knowledge about the alkyne. So first, alkyne is an unsaturated hydrocarbon with triple bonds, and the naming we like the alkene and alkane that end with the ANE. Alkyne is end with YNE. And the general formula for the alkyne is CnH2n-2. So this is the example of the alkyne. Like this have triple bond. So now let's look at the nomenclature. So same as the alkene and alkane, the nomenclature should choose the longest carbon chain that contain the triple bond. So we should pick the longest chain that have triple bond. If no, we cannot pick that. So for the naming of the alkyne, have one point that should be very careful is, so normally we give the nomenclature based on the priority of the functional group. So you can see the priority of the alkyne actually is lower than the alkene. So it means that if we have double bond and triple bond at the same time, we should give the numbering from we should give the numbering start from the alkene first. So the lowest numbering start at alkene 1, 2, 3, 4, 5, but the parent name is still alkyne, YEN. So like this. And then if the numbering here, sorry, here the priority in our parent is alcohol, the alkyne is at the middle. Actually, we write it as YN, not YNE. So actually, the alkyne have two types. The first type is terminal alkyne. They have the triple bond at the end of the carbon chain here, like this. So he have the acetylated hydrogen. This is terminal alkyne. The internal alkyne means that the triple bond is on at the middle, so the alkyl is on the both side. This is the internal. So the reaction will be different based on we using the terminal alkyne or the internal alkyne. So now we look at the physical properties. Actually, the properties is similar to the alkene and alkane, which is insoluble in water, soluble in organic solvent, and also first we look at the reaction. Now it's reaction. The first reaction is the this is preparation. Alkyl halide dehydrohalogenation. How we can form an alkyne is from the alkyl halide. So if we want to form the internal one, the Br should be also in the internal part here, and using the reactant KOH with 200 degrees Celsius, and we will form the triple bond at the middle here. If you want to form the terminal one, the Cl also need to have be at the last C, and then using the reactant NaNH2 in 150 degrees Celsius and H2O. So the next is the reaction of acetylite ion. So the alkyne, terminal alkyne, will react to the NaNH2 and the liquid NH3 to forming this. We call is the intermediate will form C two lone pair negative and NH plus, and this thing will further go to the reaction with the alkyl halide to form the longer chain alkyne like this. But this reaction only available for the terminal alkyne. If internal alkyne, they can't do this reaction. So the next reaction is the hydrogenation, which is adding H2 in the catalyst of HPT, PD, and Ni. So this is basically same with the alkene, but the only special thing is if you want to completely sorry, if you want to completely forming the alkane, you should use 2 mole of H2. If you want to form alkene only, you just use 1 mole of H2. This is the most bigger difference. And then we have the next is halogenation. Same thing, adding halogen in the presence of CCl4 or CH2Cl2. So the same thing, if you want to completely forming this from the alkyne, you want to form alkyne, you want to form the uh alkyl halide with the double bond, you should use the 1 mole of X2. If you want to completely form like all substitute with the X, you should use 2 mole of X2. So the next is hydrogen halide, which adding HBr. So the triple bond will break and then adding one H and Br following the Markov rule. So if you want to completely forming like this, you also need 2 HBr. So the next thing is the ozonolysis. From ozonolysis, we have two types of the reactant. The first type is O3H2O, this, and the second type is this, KMNO4, KOH, and HCO plus. If you realize that we also have this similar reactant in the alkene part, but for alkene, different reactant will form different product, but in alkyne, the difference is if you're using terminal, no matter which reactant, if you use terminal, you will form carboxylic acid and CO2. If you use internal, you will form 2 carboxylic acid. No matter which reactant you use, it will form the same thing. So the next is the visual test. So we have 3 visual tests. The first 2 is same with the alkene to differentiate between alkyne and alkane. So first is bromine test. Similar with alkene, we use bromine, but in here, 2 bromine in CCl4. So the reddish round of the bromine will become decolorized. The second one is KMNO4 diluted, cold, and also in basic condition. Like this, it will form a diol and also a brown precipitate. This MnO2, this arrow means that it is a precipitate. So the next is the important one. The third visual test is to differentiate between the alkyne and also terminal alkyne and the internal alkyne. So here we use AgNO3. So it will this only available for the terminal alkyne. It will have reaction. The H will be displayed like this, Ag plus. But for the internal alkyne, they won't have any reaction. So you can see here, this is insoluble precipitate, so you can differentiate between the terminal and also the internal alkyne. So in conclusion, today we just learned 3 things. Alkane, alkene, and alkyne, both 3 is hydrocarbon, and we learn their nomenclature, their also their properties, chemical properties, and also physical properties, and also we learn their preparation, how we can form those things from other uh, um, product, and also the reaction like hydrogenation, hydration, halogenation, oxidation, and so on. So thank you for your listening. That's all from me.